In this video, we're going to talk about ways that you can multiply more complex numbers, or more complex expressions, I guess you should say. Uh, let's start with something that we know. We know for a fact, of course, that this thing here, that this first expression here, that this is going to be 6 times 7, which is going to be 42. So everything we're going to do for this side over here, we know it should come out to be 42. Now, one way that we could do this is, like I said, we could add together this and we get our 7 here. But we're going to see in upcoming examples, well, what happens if we can't add those things together? How do we multiply them together? So let's start with this. So if let's pretend that we can't add these two things together. So of course, one way we could do it is we could say, I'm going to take 6 times 3, and then I'm going to add 6 times 4. That will also be a method for multiplying these things together. So that would be 18 plus 24, which gives us a value also of 42. Now, again, some of these that we're going to do, they're going to be a little bit more complicated. So let's see, and it's going to get even more complicated than this. So let's use a method that will allow us to do this, and that will kind of be methodical in practice. So what I'm going to do is I'm going to look at what happens if we try and find the area of the pink rectangle, and we're also going to try and find the area of the purple rectangle, two different parts of this whole rectangle. We know if we find the area of this and we add the area of this, that we're going to end up with the area of the whole thing. So if we use these as dimensions for this rectangle, we can find that very thing. So let's take 6 and we'll put it up here, and we'll do that because there's only one number here, so we've got one dimension here, or one piece here. Here we can see this is broken into two parts, so we'll put the 3 and the 4 in there. So let's put 3 here and let's put 4 down here. So if we take 6 times 3, we of course are going to get 18, just like we did before. If we take 6 times 4, we're going to get 24. And so here we have our 18 plus 24, and we get our value of 42. Of course, like I said, that's what we already know. We already know how to do that. We've done that many times. We know what that outcome should be. So this one also, for this 4 times x plus 2, this could also be done the same way. We could look at 4 times x and 4 times 2. And maybe we see, okay, so 4 times x plus 4 times 2. So we should come up with a result of 4x plus 8. But let's, again, use this model in order to show how this works. So again, here's one part. So I'm going to put my 4 over here. And then I can put my x plus 2 right here. So here's my x plus 2. And I'm putting the plus sign in here just to help keep track of this, this being a positive value. So again, let's look at what happens if I find the yellow box and the green box. Well, we already know from up above that from here it should come out to be 4x plus 8, but we have 4 times x, and then we've got 4 times 2, and if we want the area of this whole thing, we just add those together, so we end up with 4x plus 8. Great. Now you're probably saying, yeah, okay, that's great. I can do all of that. But what happens if we have one of our dimensions being x? Now, that doesn't really change anything. So I'm going to put x here, and then I'm going to put x plus 3 here. So again, looking for finding the area of this piece and finding the area of this piece. So here I've got x times x, and then I've got x times 3, and I'm going to add those two things together. So I've got x squared plus 3x. So here's how we can start multiplying these together, or this together. It comes out to be x squared plus 3x. All right, so now here's the big one. So now we've got, like I said, we're going to use this for more complicated methods or for more complicated expressions. So here we've got x plus 1 and x plus 3. So I'm going to do the same thing. I'm going to break it up into these parts here. So I'm going to look at x plus 1 and x plus 3. I know, well, I guess if we wanted to make it match, let's do this. We can make it match so that way it looks a little bit nicer. We'll do x plus 1 here and x plus 3 here. And you can also see that it doesn't really matter which one you put on which side. It really doesn't matter at all, just as long as you're doing all the multiplication and adding together. So we're going to start by finding the purple box, and then we'll find the red box, and then we'll find the green box, and then we'll also have to find the yellow box. So when we find all of these, when we add all of them together, it will give us the area of this box here, or this square here. So let's start. X times x is going to be x squared. X times 3 is going to be 3x. X times 1, for this piece, x times 1 is 1x. And then finally, 3 times 1, so this dimension 3 times 1, we get 3 times 1, which is 3. So now I'm going to add all of these end results together. I'm going to add all of these things together. So I'm going to start with x squared plus 3x plus 1x plus 3. So again, this comes from purple. Oops. This comes from purple. This comes from pink or red. This comes from our yellow. And this comes from our green. So x squared plus 4x plus 3. And we can combine these because they both have a single x. We cannot combine this term with these because this has an x squared term, and these have just a single x or x to the first power. So we can combine these two pieces into 4x, and then 3 doesn't have any x's, so it's by itself as well. So here we are with the product of these two binomials. We have x squared plus 4x plus 3. And this is the area model. Now, maybe we want to use a model called the distributive property. This is really just using the algebraic process of how do I multiply two things together. So to do that, what I'm going to do is I'm just going to break apart these parentheses. What the distributive property says is I need to make sure that this x is multiplied by everything in here, and this 2 is multiplied by everything in here. You'll see that it's very similar to the area model that we've done before, but we're going to now just do it algebraically. So maybe we change the color of this one here. Let's change this to purple. There we go. Oh, I got one too many. Let's change this back to black. And all right, so we're going to take this x, and we're going to whoopsies, lost our work there. So we're going to have x times x plus 6. And then we're going to take plus 2 times x plus 6. So when we multiply this inside for each one of these things, I'm going to have x times x, which is x squared. I'm going to have x times 6, which is 6x. I'm going to have positive 2 times x, which is positive 2x. And then I'm going to have positive 2 times positive 6, which is 12. Now I'm going to combine any like terms. And I'm left with x squared plus 8x plus 12. And there is our product of these two binomials. It doesn't matter if we've got a number in front of our x here, we could still do the same thing. So let's change this. Maybe we'll make this green. Let's make this one green. So we're going to take our 2x and we're going to multiply it by x plus 10. So 2x times x plus 10. And then we're going to take a positive 5 and we're going to multiply it by x plus 10. Now we're just going to take this 2x times x, 2x squared. 2x times 10, that's going to be 20x. 5 times x, positive 5 times x, is going to be positive 5x. And positive 5 times 10, or positive 10, is going to be plus 50. I'm going to combine my like terms. And what I end up with is 2x squared plus 25x plus 50. And now we have multiplied those two together. And so this is our distributive property. And again, what this does is this helps us break apart these parentheses and make sure that everything inside this parentheses is multiplied by everything inside here, or vice versa. And same over here. And now you could break this one apart as well. I just chose to go left to right. So hopefully this helps you understand how we can multiply two binomials together.